Hello and welcome back to Statistics1. It's time to take a look at descriptive measures for population, which means mean, standard deviation, and something is called z-scores. Let's see what this is all about. So mean, population mean. So population mean is going to have a different notation. We are going to use mu, and it's going to be sum of all xi's divided by capital N. So this is your formula. To put this formula in words, mu is population mean, xi data points, all of them, and then capital N number of data points. That was for sample is lowercase n, for population is uppercase n. They show the same thing. How many you have, how many numbers or values or objects you have in your set. So how many observations? And again, this symbol over here means add all of them. So that's the population mean. And then we have population standard deviation. Oh, I forgot to say that the symbol is mu. It's a Greek letter, equivalent to our M. Now, population standard deviation, the formula is a little bit different. There is no -1 in denominator. So, sigma, it's like a O with one horn. The other horn is missing. So one horn only. Only the right horn. So sigma is the square root of, and the formula is the same. It's xi minus the mean. We used to have mean squared, right, over n. So this used to be x bar, because mean for sample is x bar. Now mean for population is mu, so we are using mu. So the symbol over here, the Greek letter sigma. Sigma. This is our formula. We already know what each one of these means. Xi, individual entries, mu is the mean, and capital N, the number of numbers we have. And the last one that we are defining, and then we can do the problem, is going to be z-score. Z-score. And z-score is going to be, is just a simple formula. Z equals x minus mu over sigma. And we need to know what it does. So z-score calculates how many standard deviations the data point x is from the mean. So we know that we have 3 standard deviations to the left and to the right. So your z-score is generally between -3 and 3. Right? So I'll put that. It's not a rule. You can have z-score as negative or +4, right? We did say that Stephen Hawking was clocking 160 on IQ scale, which was 4 standard deviations. So that would be z equals 4, because he was 4 standard deviations above the mean. We can also find a person that has IQ of 40, right, on that other end, and that would be z-score of -4. So we can have bigger numbers, but we know from that lecture that we skipped that 99.7% of your data lies between those 3 standard deviations left and right, right? So chances are that all of your data is going to be between those two, and that's why we say usually z is in between -3 and 3. Here in parentheses, it can be more. And I'll put 1. Not too much, just 1. So here are the three formulas. Formula for the mean, formula for standard deviation, and formula for calculating z-score. Z-score is going to be calculated for each number you're interested in individually. So I'm going to pick an example from homework and just run all of these 3 formulas against that one example. We're going to pick an example that has few values, like 3207. And those entries are 29, 54, 4, 45, 51, and 7. So this is your population. Which means capital N is equal to 6. You have 6 entries. 1, 2, 3, 4, 5, 6. 6 data points. So capital N is equal to 6. Mean is going to be 29 plus 54 plus 4 plus 45 plus 51 plus 7 divided by 6. These numbers add to, I'm sorry? 190. And we divide that by 6. So it's going to be 31. Let's just put 31.7. 1 decimal extra from the data. So now we have our mean, 31.7. This is population mean. To find standard deviation sigma, we have to run summation of xi minus mu squared divided by capital N. So I need a column for my n's, and those are my data numbers, so 29. We could have put this in the order, but I didn't. And now I need, so these are, these are my xi's, which is n is equal to 6. I'm losing my mind. These are my xi's, every individual data point. So the list of xi's, and now I need xi minus mu. So I have to subtract 31.7 for all of these. So negative 2.7, 31, so that's 23, 22.3. 4, that's going to be negative 27.7, I hope. 45. So what's that? 45 minus 31 is 14, so 13.3, right? 51, 54, so minus 3, that's 19.3. And then 7 should be just 3 more, so negative 24.7. Are we all good on these? Yeah. Now I need squares of each one of these. So we need to square. Negative 2.7 is like squaring 2.7. So 2.7 squared is 7.29. And then 22.3 squared is 0.29. Thank you. Then 27.7 squared.
767.9.
And then 13.3 squared is
176.89.
Thank you. 19.3 squared.
372.49.
And finally 24. 0.09. Great. So we obtained everything in parentheses squared, each one, and now we need to add them all. So maybe it will be faster if we just add them without the calculator, because we have 9s everywhere. So that's 6 9s. 6 times 9 is? Very good. 54. So there's a 5. Now 2, 4, 14, 18, 23. So there's a 2. Now 2 and 2, and that's 10. That's and 21, 31. Now we have a 3. That's 10, 11, and 13 is 24. 24, right? And then 33. 3. That's 10, 20, 24. There we go. So now my sigma is square root of 2431.34 divided by capital N, which is 6. So sigma is equal to square root of 1624 goes 4 times, 16.3 doesn't go, 1631 goes 5 times, 1613 goes twice, and 1614 goes twice, and then there is more decimals, no one cares. Square root of 400 is 20, so this is about what? 20 point something. 20.1. So we have our population standard deviation to be 21. So population standard deviation is given as 20.1. And now I would like to know 7, let's say. Find z-score for x equals 7. So z-score for x equals 7 is 7 minus the mean, and the mean was 31.7. Divided by 20.1. And what is this value? It's going to be negative, obviously. 1.23. Now I need to write the meaning for this, and we're done. So x equals 7 is 1.23 standard deviations away from the mean. That's all it is. Z-score measures how far your observation is for the mean. If that observation was Stephen Hawking, then 4 standard deviations away from the average. So these are the three calculations. You see that they're exactly the same. The mean and the standard deviation are the same as we learned earlier for sample. The only new calculation you have in this, well, you have all the new symbols for population. The only new calculation is the one for the z-score, and you need to learn. This z-score will be on a test because we are heading into 4 or 5 chapters that will be using z-scores. And we'll also learn t-scores as well. So this is going to be one of the biggest concepts of our course. This has to be on a test, this calculation. So learn and understand what it means. It simply measures how many standard deviations, observation that you picked, or observation that I assigned, or the homework assigned, how many standard deviations that observation is away from the mean. In order to calculate, you need the mean and you need the standard deviation so that you can compute that thing.
You put it into a rate, and you say away, that's a negative, that's different than a positive.
Oh, from the mean to the left, you're right. Haha. From the mean to the left. Or how many standard deviations? So x equals 7 is 1.23 standard deviations away from the mean to the left. Yes, you're right.
Can you just say below? Or no?
Below the mean, sure, why not? Because the data is ordered, right? The numbers. Good, sure. Whatever makes you smile. You know, this is a math class. We should all be happy at all times. I just like United Airlines. What?